In the last two videos, we talked about translation and reflection. There's one last of these transformations that maintain congruence, and those are rotations. So let's take a look at those. Once again, in GeoGebra, I will create a triangle. And when we do a rotation, there are two things we need to specify. Can you imagine what they are? Well, the first thing we need to specify is a point that we're going to reflect or to rotate around. This is going to be the center of our rotation. And the other thing we need to specify is how much we're going to rotate by. So let's take a look at what that looks like. So if we're going to rotate around a point, the first thing we do is select the object that we're going to rotate and then the center of the rotation. And now we want to put in some angle and have it be either counterclockwise or clockwise. Clockwise is the direction the clock hands go in when they tell time. Counterclockwise is the other direction. So let me do a clockwise rotation of 90 degrees. And you can see that this is what would happen if we had this on a piece of tracing paper and I held my finger down on the D and twisted the paper by a quarter of a full turn. The triangle would wind up there. Here's a really nice thing that will help you with some IXLs, that if we draw a line segment from A to our center of rotation and from A prime to our center of rotation, this angle that it forms is the 90 degrees that we rotated by. So you can see that going from the center to A to the center to A prime, we're going 90 degrees clockwise, which is exactly the rotation that we specified. There's nothing special about A there. We could also do the same thing with B or with C. Another thing you can notice is that these two line segments are the same length. So BD is congruent to B prime D. So those are important notions when we're talking about rotations. Another important point, like with the translations, like with the reflections, is that these two triangles are congruent to each other. So once again, line segment lengths are preserved when you do rotations. From A to B is the same length as A prime to B prime. Angle C is congruent to angle C prime, and the two triangles are congruent. So that's what makes these three transformations, which we will call rigid transformations. Rigid transformations are important because rigid transformations are going to preserve congruence of line segments, angles, and figures like triangles. So that's going to be one of our key ideas moving forward as we start talking about what congruence means and how we can define that in more precision a little bit later on in the class.